Hello everybody. This presentation is called The Stages of an Angular Architecture. And here we will learn how to create the right architecture for your Angular applications and the different architectures you will encounter as your app grows. Here's what we're going to cover. What is architecture? What does that mean? Clean architecture best practices in Angular apps. The stage 1 of the architecture with best practices. How to use NX and the best practices with NX mono-repo architecture. Stage 2, which is where we're going to see how we can use these NX best practices and utilize layers and domain-driven design to create a scalable and clean architecture with NX that can scale even further. So, first, a little bit about me. I am Christian Lydemann. I'm an Angular consultant, speaker, trainer, and blogger. I'm from Denmark. You can check out my blog here on christianlydemann.com and also on my GitHub at Lydemann and on my Twitter at Chris Lydemann, where I post Angular tips and blog posts. I have my blog where you can go for weekly new content. It's a lot of practical and applicable knowledge related to Angular apps, and you can join more than 50,000 monthly visitors on my blog. So the background for this talk. Usually things start simple on Angular projects, but the architecture might grow in an unmanageable way if you don't build it with the right blueprint that can handle such scale. Building apps with clean architecture best practices make sure that development time doesn't increase as the code base increases. As that is usually what happens, that it will take longer and longer time to develop new features, as it's harder to find the co-located files maybe for a certain feature area to be working in. Or maybe there's just a bunch of bugs and side effects that, different parts of the app that explodes when you touch one part and it's not really manageable in that way. What is architecture? So the Martin Fowler definition is software architecture is those decisions which are both important and hard to change. It's like the blueprint of the solution, like it is for buildings. A good architecture makes it easy to change the system later. So architecture is an enabler for change of the system. The better the architecture, the easier it is to change the system. And why is architecture important in Angular development? As I just said, it's hard to change later, so you have to build the right foundation. Like for building, you cannot just change the blueprint after it's built. And code is read 10 times more than it's written. So you want to optimize for that and make it very readable. And especially in the front-end landscape, technologies change really fast. Like one moment it's RxJS, then it's Signals, then it's this new state management library. All these changes your architecture should accommodate and should be able to handle this without you needing to rewrite anything. So you have to keep this in mind. And how you should prioritize a clean architecture is you can use Eisenhower's matrix, as that is a way to prioritize tasks based on importance and urgency, where the most important thing of the application, that is even more important than clean code and architecture, is the key revenue generating or cost saving behaviors of your app. As much as we like to be perfectionist about our craft, that has to be the most important thing, that either generate revenue or save costs. That is what our systems are doing. But architecture, that's an important thing. It's important because it's accommodating change. If you have a system you cannot change, then it's going to be unusable in the future. And then on the third place, we have unimportant but urgent. And that is these things that is not really, it's not really any key revenue generating or cost saving behavior, but it's still something that should be fixed. But architecture is something that is even more important, and it has to be something that we continuously invest in, and we definitely have the right blueprint, which is what this talk is going to teach you. So what is a good architecture? First of all, the key purpose is to accommodate change of the behavior of the system later. So it reflects the domain instead of the technologies. It decouples controlling mechanisms and details. For example, UI decoupled from the business logic. It makes it easy to change details later, like state management framework, UI framework, and communication framework. As I talked about, this is something that is often changing in the front-end world. So it should be built to last a storm, as the weather can change quite a lot in the front-end world. Let's look at some clean architecture best practices in Angular apps. So this is something people find even in the Angular style guide. So we want to group by domain, or we also call it group by feature, which is the principle that you have things that are related to a feature grouped together in the same folder as these files that are related to that feature. Usually you would want to access them often when you're working that feature, so the cohesion becomes better. And also it comes from domain-driven design, where you identify the different domains and terms in your in the domain you're working with, and then you structure your architecture around those rather than structuring around technical jargons or other things, as the domain is always going to be about those terms and not the technologies underneath. So when we look at the top level folder structure, it should look like this. So we want to model the architecture around the domain. We want cohesion within that domain. And a good metaphor is like when you go to a store like IKEA, you don't want to, for example, if you're looking at something for the bedroom, for example, you don't want to go in one place of the store to find like the legs of the bed, or one other place of the store to find the mattress. You would expect that to have cohesion and be in the same area. The same way with your code. When you're working with one domain, you would expect within that grouping folder to be able to find the UI, the domain, logic, and such. Other thing we have is using abstractions, and here we have facades and design systems. So abstractions, those are key principle in clean architecture, because abstractions enables easy change in the future, because we have some indirection. We don't depend directly on the things, so we can change the underlying instance of the abstraction that we're working with. And abstraction, they also control dependency flows. So, for example, we can enable a domain layer to indirectly call the UI layer using an abstraction. So one of these abstractions you often will see in apps is creating a facade, which will be like a service that could be used in components. And that can contain business logic, and it acts like an interface for the underlying state management and the domain logic. And it gives the container component what it needs to accomplish its use case. And it ensures encapsulation of the business logic and data access. So the UI shouldn't know about the specific network protocol used to get the data, for example HTTP, or the state management solution, for example NGIX. And that makes it way easier to change NGIX or the whatever underlying state management solution later on. And then creating even more simplicity in the UI layer. Also, especially with signals now, it's a common pattern now to let the facade just present stuff as a signal, which makes it even more simple, because signals are a lot simpler than RxJS to work with. And if you think about it, this is not a new principle with the facades. This is coming from like backend development 20 years ago, where we, for example, had SPDNet MVC, where you would have a controller talking that is like accommodating all the taking the API request in and the delegating to like a use case facade, which is then talking to like some domain object, rather than the controller talking directly to the database with SQL commands that you definitely didn't want. So the same way for the front end, you want these kind of abstractions in place like a facade. And then we have design system and UI kits. The same goes that we don't want everywhere to reference these exact instances, because then it's very hard to change later. If everywhere we depend on some UI kit, a UI tool everywhere, then it's going to be hard to change that later. And also we want some abstractions, for example, we don't want colors to be referenced directly. Instead, we want some color schema that has some alias for the color, and the same for spacing. So it's common for companies to have design systems that provide these reusable UI components. And also it's common to use something like Tailwind CSS to provide these classes where you have like a schema for the colors and for the spacing. So all this in place, gonna make it a lot easier to manage change of the application. You can change, for example, the spacing of the color schema without updating every usage around in the UI layer. And then we have single responsibility, where we have principles such as container and presentational components. We have slim components, where we want to keep things slim and single purposed, and then small files. So single responsibility, every module should only have one responsibility for its abstraction level. You can use this 3-second rule, where you should basically get the grasp of what a file is about within 3 seconds. Otherwise, probably you don't work with the right abstraction level. Probably you have some lower level details that you could delegate to make it more readable. And then we have the container and presentational component pattern, where container components are the ones that can inject services and know about the feature-specific context. It can inject dependencies and is responsible for delegating, and it's wrapping the presentational components. Then we have a presentational components, which is like UI only components, and that is for breaking up the template of the container component, and it's just responsible for presentation, and it uses input and output for all interaction. So this makes it more reusable. You can move it around and use it in different contexts, whereas container component you cannot just move around, because all the dependencies it's injecting is making it dependent on a specific context. Then slim components, you should delegate to services instead of keeping like domain logic and stuff within the components, because components are for UI, so we want to keep it about that responsibility and then keep it as small as possible. Then we have slim components, where we should delegate to a service. As components are responsible for the UI, so we want to keep it as small as possible, and we want to offload logic to a service or to like a facade, like we talked about, as components are for the UI. And we want to keep things small so they're easy to read, and also we make sure to keep a consistent level of abstraction and all these other clean architecture best practices we just talked about. You can set an ESLint rule to ensure the max line of a file using the max lines. And if a file gets too big, we split it up, like we create presentational components and delegate to services. A common recommended max line is 500, so you can use whatever is appropriate for your needs, but usually I would go with 500. So the first stage of your architecture when you're starting out, which I recommend, which can also like scale further when you need it, is just use grouping, domain and feature folders. Base your architecture around that, this domain-driven design principle, as this gives cohesion within these related files. This is the opposite of having one big component folder are one big directive folder and these technology specific folders on the root level, as that's not scalable. What happens when you have 100 components in different kind of domains? It's going to be impossible to navigate around. So better to group using grouping folders around the domain or feature you're working with. So let's consider a to-do app and see how this might look. So this might look something like this, where we have the apps, for example, to-do app, and then we have to-do list. We have within that a feature folder, and then we have domain to split these two responsibilities. And then within the domain, we might have the to-do list facade, which is encapsulating the state management solution that can then provide the data we need in the feature, which is where we have the page components, the container components for the to-do list. If you have different apps, we might still have a shared folder within libs, and where we have maybe some reusable UI components, some shared domain, maybe some setup of NGX here, some utilities, and maybe some of like the login and the auth service here. So this is a simple architecture that works to start out with, and it gives nice cohesion, and it's actually what I recommend for starting out, and it's what I do myself when I create new projects. But at some point you would want something that's more scalable, and this is where you can use the NX tools for making that happen, combined with a layered approach. So when things start to scale, we need a more efficient way to run commands on our code, like running test, lit, and build without running it on the whole code base. Oftentimes when an app is scaled up, you would have something like the Spotify model, where you would have a feature team per feature area working on that, and you want some kind of like separate way of working with your feature area, and then you have a way of combining those things. NX is a build tool that lets you run commands on only affected projects. So if one project is only affected, then you only need to run test, lint, and build on that. It ensures control of dependency flows with defining module boundaries as ESLint rules. And you can get schematics and executors from many different frameworks and tools. So it's really framework agnostic. It's not only Angular, it's based on the Angular CLI, and it looks a lot like the Angular CLI, but it can be used for React and Vue, and it's a replacement for Angular CLI actually. So the layered architecture is defining different layers within those domains or subdomains of our architecture. And that is to ensure a one-way dependency flow and a separation of responsibilities. So we can split the architecture up into different kinds of layers and domains. One-way dependency flow is necessary to avoid cycles in our architecture, and it's necessary to keep things scalable and predictable. So such a layered approach, I define this like this, where we have the shells that exposes the feature libs from subdomains referenced by apps like route, lazy loading. This is something you would normally have if you have like multiple subdomains, and then for each of the feature libraries you would expose them through a shell. Then you have the API that can expose the UI domain and the util layers of that specific subdomain. You have feature, which contains smart components, which is the pages or the models. You have the UI which is the use case agnostic presentational components or directives. Oftentimes these would go in a shared folder, as this is something that can be used regardless of the use case. So you just want to expose that and make that reusable for the whole application. Domain contains the facade, the state, the HTTP, services, interfaces, and all the domain specific logic. And then you have util, which is domain agnostic helpers, and that's often something that would go in shared as well, because often like domain, like date helpers and stuff, you would want to be accessible to the whole architecture. So dependency flow, to show this is an example from a banking application where we see this architecture in practice. So this is the different layers like feature, UI, domain, and util, and we have the API to expose the UI, domain, and util to other domains. And it's only the feature libraries that can access the API, and that is to ensure that the layers can only talk down, and that is otherwise we could get circles in the application. And also the API enables us for keeping things cohesive. If we didn't have the API libraries, what would happen is when another domain would need to access something from another domain, then that would have to go to the shared. And then we would have a lot more move to shared, and then we would lose the cohesion of having everything grouped by the domain. So this is a better approach to go this way and keep everything as cohesive as possible related to that domain. Sometimes you still have to put something in the shared domain. For example, a service need to call another service, then sometime if it's really truly a shared, then you would move down to the shared. But this is to minimize the stuff that goes to shared and keep it more cohesive related to the domain. And otherwise, this, you can see there's no circles in this. And this is a rather scalable architecture for this particular app, where this is a small snippet of. We were more than 50 developers working together, and there were way more domains. As you see here, there were more than 10 feature teams working on this app. So I see this being very scalable with this approach. There are some gotchas when you do this approach, as it's a one-way dependency flow. Sometimes the domain has to trigger UI. For example, when you want to delete something from the domain service, you often want to show like a dialog, a model to confirm that you want to delete something. And you can handle this by either injecting some abstraction, using abstractions in the domain layer, and then inject the specific UI service using Angular's dependency injection. Or you can also create an NGX effect in the feature layer and then call an action from the domain layer. Either way, it's an indirect way to call up to the feature. And then you still obey the one-way dependency rule. So this is like the gotcha that I often been asked about. And then if you want to scale even further, now we can apply some of these techniques with NX to the existing StuApp architecture. So let's see how that would work. So let's say that the app really starts to grow and we have way more features, and we start to get, let's say, over 1,000 tests. We have a dedicated feature team for each feature area, starting to follow like the Spotify model. We need to publish some parts of the app independently. For example, we need to package something, or we need to publish micro front ends. So we solve this by moving the grouping folders to libraries, and then create a library for each of the underlying categories like feature or domain, like these different layers we saw before. So let's see how that will look. So here we see how the to-do app is rather empty now. It's basically just some configuration and some routing configuration, some bootstrapping and routing configuration, what it is now. So when we, for example, go to the root route or the to-do list route, then it will load this to-do list from the to-do list feature library. See, that's the library now, within the grouping folder to-do list, and then that is calling the domain to-do list library, which is a folder within this. Usually I would do it like in the folder structure would be like to-do list, and then it will have a feature library and a domain library underneath this. This is just the actual name of the libraries that it will have. And with this approach, when a change is happening to the domain to-do list, then only affected projects will be retested and run the rebuild. So it can really speed up things when you start to have multiple apps. And with same way with shared also split up, for example, with auth, you have the feature and domain libraries, and you have a UI library that is shared, and you have domain library and util. This is a very scalable architecture. This architecture can easily have 50 developers working together. Some of these apps might be micro frontends that has to be loaded through to-do app using module federation, or has to be packaged. There could even be a design system in here that is being packaged. It can handle a lot of scale for a big part of your organization, just one of these monorepos. And it's so easy to share code when this group is set up, because you can move, if you create some reusable stuff here, like a reusable UI component, you can just move it to UI, and now the whole architecture with all the different apps now have access to it. So take a good look at this architecture and see if that is something you need right now. Otherwise, you saw the other variation where we just had grouping folders, and we don't need to have like those smart linting and smart builds, but we're fine with everything being, all the commands running for all the code every time we commit. Then that might be fine for you. This is just the way you can scale up as you start to get to that more scaled area with like multiple feature teams. So to wrap up, follow the clean architecture best practices first of all. That's the most important thing. And then aim for the solution that fits your scale and scale up as needed. It's better to start small and with the scalable blueprint, and scale up rather than starting with an complicated and engineered solution. And you can start enjoying maintainable scaling of your architecture. And also one more thing, if this is something you want to learn more about, this is also something I am coaching my students in Angular Architect Accelerator, which is my 8 weeks online Angular architecture course. It teaches you everything you need to know to work as a high-end Angular architect. The end result is getting promoted, getting a remote job, or become a highly paid freelance consultant with the course. So you can join a free warm-up workshop where you also will learn more about clean architecture. You will learn more about performance tuning and how to accelerate your Angular career. So you can go on christianlyderman.com/accelerator and sign up for the free workshop. So let me know if you have any questions, and thanks for watching. The slides will also be shared on my Twitter, which you can go and follow at Chris Lyderman.